Right, hello, Math 1052 students. I'm going to do question number 17 of the Unit 4 Review 1. This will cover equivalent payments, which was the lesson earlier today. Today is Thursday night. So here we go. So question 17. What single payment 6 months from now would be equivalent to payments of $500 due but not paid 4 months ago and $800 due in 1 year? Assume money can earn 7.5% per annum compounded semi-annually. Okay, so the first thing you got to do with an equivalent payment question is to plot the timeline. Very important so you understand the question. Okay, timeline here. Okay, so the first part of the timeline will be the earliest date. In this case, it's, what is it? What's the earliest date? The earliest date is $500 due but not paid 4 months ago. Okay, so this is 4 months ago. 4 months ago. So that means it's in the past. So we have now. But where now is in the timeline as well. So 4 months ago, we had a payment of $500 that was not paid. So in this particular case, it's you can suppose or imagine that the payor has missed a payment, right? Now, so you've got now there, and you've got $800 in the future, due in 1 year. Okay, so that will be the second payment, so that will be the end of the timeline. All right, in 1 year. So that's $800. Okay, and the payer would like to settle the debt in a single payment 6 months from now. 6 months, that would be the focal date. 6 months from now, so you put it around here. All right, so this will be 6 months from now. That's 4 months before now and 6 months after the present day. So this is the focal point. All right, so what we need to do, as I discussed in class, is to get the future value of the payment, the earliest payment. In this case, there's 2 payments, 1 and 2. So you need to get the future value to get E1 and the present value of the later payment, right? This way, E2 at the focal date of 6 months from now, right? So again, if you get the future value and the present value here, these two payments will be E1 and E2, right? Okay, so let's figure this out. How do we do this? So first, we have to figure out what the I is. Okay, the I, and if you remember the formula of I, equals J, which is the per annum interest rate, divided by the number of compounding periods per year, which is M, right? That's the I. So I is going to be the same for both the 500 and the 800, right? Because look at the question. It assumes money can earn 7.5% compounded semi-annually. That means it's for both payments. So there's only one I, right? But there's 2 N's, as I will discuss shortly. Okay, so what is the I? So you just plug in. The J is the 7.5% compounded annually. Per annum. So that'll be, put it in decimal, 0.075. Okay, and what is the M? M, again, that's the number of compounding periods per year. If it's semi-annually, that means that the money is compounded every 6 months. So there are 2 6-month periods in a year, so it's if it's semi-annually, it's compounded twice. Okay, so that's 0.75 divided by 2. That'll equal, get the calculator here, okay, right, 0.075 divided by 2 equals 0.375, or 3.75% per 6-month period, or per compounding period. Okay, so that will be 0.0375. That's your I. Okay, now the ends will be different, right? In a problem like this, the I is always the same, but the ends are different. Right, so how do we calculate the ends? First, we have to calculate the end for the future value. It's a good idea to kind of lay out all the givens first before you start calculating the future value and the present value. Okay, let's calculate the n for the future value. Right, so the n, let's say it's n1, corresponds to the E1 here. N will be what? Okay, so how many compounding periods? So let's just review. Okay, so the n is equal to number m compounding periods per year multiplied by the time in units of years. Okay, so n1 therefore will be m is always 2. 2 multiplied by the time in years. All right, so what's the time in years? So you've got to get so 6 months plus 4 months, because you want to get the future value from 4 months ago to 6 months from now. So what would that be? How many months would that be? 4 months from here to now, so that would be 4 months. So let's say 4. And then from now to 6 months, that's another 6 months. So 4 plus 6 equals 10. Okay, so that would be 10 months, right? 10 months. Okay, so it'll be 2 times 10 months, but 10, that's in units of months, not in years. So you've got to put a denominator of 12. That's the line there. 10 over 12 to make sure that this is in unit of years. Okay, so since it's months is what you've been given, you've got to divide it by 12 total months per year to make it in units of year, so that's consistent with the per annum interest rate of 7.5% here. Right, you multiply those together to get the N1. That'll equal this will cancel out, 1 and 6. So it'll be 10 over 6. 10 over 6, or 1.66 unto infinity. Okay, I'll show you how that comes out in the calculator. Right, so okay, so 10 divided by 6, sorry, 10 divided by 6 equals 1.666 onto infinity. Okay, or see, that's how we do it here. So you divide or if you can also do it this way. All right, so what you can do is you can get 10 divided by 12. Let's say I didn't cross these two out, equals that, and you multiply that by 2, and you get the same number, 1.666. Don't have to necessarily cross out the 2 and then get 6 or 10 over 6. You can just go 10 divided by 12, multiply it by 2, you'll get the same number. Okay, so that's n here. So it'll be useful to also get the n2 for this part. So n2 would be equal to, right, again, m is the same for both sides. M, because there's 2 compounding periods for both this payment and that payment. They've got the same interest rate. So 2 compounding periods per year. Now you got to get the time in terms of years. So what is that? So you've got to get the time 1 year minus the focal date of 6 months from now. Okay, so what is the difference between 1 year from now and 6 months from now? It's 6 months. Okay, because 1 year is 12 months from now. So 12 minus 6, that would be equal to 6 months. Okay, 6 months, but that's in units of months, not in years. Put the 12 below to make it units of years to be consistent with the per annum interest rate. Okay, so that's your equation. 2 times 6 over 12. Go to the calculator. Okay, 6 divided by 12 equals 0.5. Multiply that by 2. It's 1. So N2 equals 1. Just 1 total compounding periods for this. Okay, I'm going to put this up here, and I'm going to set up the future value and the present value calculations and just simply add them together. Okay. All right, for the 500, so the future value equation equals present value 1 plus I to the nth power. Present value equation is kind of the opposite. Okay, present value equals the future value, let's say the future value 2, present value 1 here. Okay, 1 plus I to the, this is n1 by the way, to the negative n2 power here. So these are the equations you have to keep in mind. And then you simply plug in. Present value 1 is the 500. So that's 500. 1 plus 0.0375. That's the I up here. And you get the N1, plug that. 1.66 to infinity. Okay? And simply solve. All right, so let's see how that works out in the calculator. Okay, so presumably you've saved this in the memory of the calculator, but you don't really have to. You can. I'll solve it for you. So what do you do? If you have that all laid out, you just go back to just solve for the 1.66, so it appears in the calculator as such, right? So you go 10 divided by 12 times 2 equals 1.66. So there, that's that number. That's the exact number in the calculator's memory now. Okay, so store A, and then clear. Okay, so that's all clear right now. All right, to continue. So I've stored the 1.66 to infinity in memory bank A here. So I'm going to solve now, right? So let's. So I first have to add 1 plus 0.0375. So 1 plus 0.0375. So that's 1.0375. And I have to raise it to the 1.6 power. So I go function, second function, exponent function up here, right? And then I recall A. So now it raises it to the 1.6667 whatever power. That'll equal that number there. Multiply 500. Multiply that by 500, which is the this is the present value here. It's the 500 there. That'll equal 531.639 to infinity, right? So this will be the future. This will be equal to really E1. Okay, that's E1 over here. Store that in memory bank B. Right, so I go store B, and I can clear it now. So I've got E1 all set up here. Okay, so I now have to solve for E2, which is present value of the future value 2, which is the 800. All right, now I need just to plug in stuff. So future value 2, that's 800. 1 plus the same I. This one here, 0.0375, 0.0375 to the N2 is 1, so that will be to the negative first power. Okay? So how do I do that? Back to the calculator. I can solve accordingly. So I go 1, I'm going to add this, 1 plus 0.0375, 1.0375, and I raise it to the negative first power. Remember, the present value is always negative. So if your N2 is 1, it has to be always negative 1. So second function, exponent, negative, press that there, 1 equals that number, which I have to multiply by 800, which is the future value, this value here. Multiply that by, whoops, I actually pressed the, I'm going to do it again. Okay, so let's just, so I go 1.0375 exponent negative 1. I got that number again, multiplied by 800. Okay, I get the 771.0843, so on and so forth. Gotta make sure to get this whole number in the memory. So I store that in memory bank C. All right, store in C, and I can clear. So this is in C, okay? Memory bank C. Now I simply have to add these two together, this plus this. So 531.639, this is E1, plus 771.0843, that's E2. And I'll just do that in the calculator. Since all C, you recall B. That's the 531. 531's there. Plus recall C. That's the 771. And again, I've got the entire number in the memory bank of the calculator. Equals there. That's the answer. 1,302.72. I can round it because the next digit is 3, so it goes down to 72. So that's the answer. This is the equivalent payment. All right, let's put this away here. Okay, so just to review, wait, I'm gonna put this back here. Okay, right. So this, the sum of E1 and E2 is 1,302.72. This is equivalent to $500 payment 4 months ago and the $800 payment 12 months from now. Okay, why is that? All right, that's the case because the 500, 4 months ago, in 6 months will be E1. And what is E1? Is 531.639, so on and so forth. What does that mean? That means in 10 months, it can grow at this same interest rate from 500 to 531.639. You could put it another way. These two are equivalent because the $500 4 months ago has the potential of becoming 531 at this exact point here, right? And this 800, if you discount it at the same interest rate, it will become 771.843. All right, now this number here, which is that number if it was discounted backward in time to the 6-month focal point over here, you can consider this equivalent to that 800 number there, because this 771 has the potential to be exactly 800 at the interest rate of 3.75%. This one here is the 0.0375 per compounding period. At that rate, this $771 will grow to exactly $800 in 6 months' time. Therefore, you can say that this is economically equivalent to that 800 given this interest rate. All right, now since we have these two equivalent numbers brought under the focal point here, simply add those two to get a total of 1,302.72, which means that this sum is again equivalent, economically equivalent, but not equal to this number and that number. If you add these two numbers, that's going to be like it won't equal to 1,302.72. Okay, it'll be exactly 1,300, which is not the same. But if you put it all together, add the 2.72, it is economically equivalent. Okay, so that's question number 17 for you. This is the answer.